Oh, what the fuck? Oh, this fucking thing. How's it going, guys? We're back. And it was much longer than an hour's break, I apologise. But this took a lot longer than I anticipated to remove all these flipping FETs from. Alright, let's get my... let's get this little sandcastle. Put the dead parts inside the sandcastle. So that's what we do. Right, sorry about that. Yeah, the live stream... yeah, sorry about that, guys. The live stream was buffering quite a lot because my phone had switched itself to 3G instead of 4G. So I can only do the live streams when I have 4G, because otherwise the internet's not quick enough on the 3G. So I just had to quickly turn my phone to 4G. Sometimes it decides to sit on 3G all day long. Don't know why. So I've just turned it back to 4G, and now the stream should look good. Right. So I don't have a hot air blaster. So I'm literally just going to take a toothbrush and some isopropyl alcohol just to sort of clean this off a little bit. It's pretty messy. Use your phone, that's crazy for data charges. No, I have unlimited data. So yeah, I have fully unlimited data, so I can use my phone to live stream. Obviously I use my computer, but I tether through my phone. And I have unlimited internet, so I can live stream for as long as time itself. Okay, right, that'll do for that. So, for anybody who missed my live stream earlier, we are looking at an M8 Audio HK-4000D. This is not a bad amplifier. It's a pretty cool amplifier. It comes with a really funky screen on the top. So, yeah, on the top there's a screen that looks like this. Tells you voltage and stuff. And then the yeah, basically this amplifier, the top case is one massive sort of grill, like a heat grill. So it's got loads of holes in it, really big holes. And this amplifier died because a small strand of copper wire, probably some power wire that the customer was cutting, it fell into the amplifier, and probably after some time it was moving around, and then eventually it shorted out the power supply gate and source and drain and all that jazz. So the power supply on this amplifier absolutely shot itself. That's crazy. On Canada I pay $75 a month for 5 gigs. Are you fucking kidding me? That's ridiculous. What the fuck? That's insane. I pay £20 a month, which is $28 a month, for fully unlimited data, unlimited text, and unlimited minutes, and I'm not sure whether, yeah, basically everything is fully unlimited, no caps on anything for like 20 quid a month. That's a SIM only. So back to the amplifier then. This amplifier, like I say, came in with a completely obliterated power supply section. This is the power supply section. I've removed all the FETs already, which took me flipping ages because of how they are all mounted and soldered in. Absolute nightmare. I really, yeah, this is going to be expensive just purely for my time. And And because a small strand of wire shorted out the power supply FET, I wonder if the drive circuit survived. So as always, what we do is when the power supplies die, the first thing that we always do is remove all the FETs, get rid of all the short circuits, and then we power the board up with all the FETs out, and we check to see what the drive waves look like on the power supply. So I just need to work out which of my power terminals is the positive. So that's that one. And then this is ground. Yep, correct. Okay, so this is our positive one here. So I'm going to go ahead and screw our positive one in terminal in here. Sam, have you seen these Wi-Fi mod antennas? Try one for free Wi-Fi. Yeah, but it's not going to be quick enough to upload from. To stream from, I need at least like 15 to 20 Mbps upload speed. On my broadband, I get 0.1 Mbps upload speed, which is absolutely horrific. On my mobile tethering network, I get between 50 and then 20, which is good. That's what I need to live stream at a high enough quality so you guys can actually see what I'm doing and I don't look like a potato. So the remote, I believe, is this one. I'm pretty sure that's the remote. Yeah, that's this one here. This is the remote. Right, so now it's time to apply some power to this board and see whether the power supply survived. So, if any of you that have recently joined us, this is the MA audio amplifier, so 4K, and it got killed because a small strand of wire fell through the grill on the top and shorted out a small strand of copper from a power wire, shorted out some of the legs on the power supply MOSFET. So, let's turn my bench power supply here on. I'm just going to give it 10 volts. We're only going to allow 0.8 amps to pass at this point, because if any more current passes than that, then that means that there's a fault in the drive circuit, because these amps don't draw any current at all when there's just the drive circuit working. So let's see what we have. Let's see what's going on. So we have our, yes, I need to redo my scope, so let's turn that off, turn that one to 20, that one to 1 microsecond, up that to 5. So we've got 9.8 volts sitting there ready to go. So now if I probe the gates of the power supply, okay, so we have some switching going on. Nice, so that looks like a pretty good square wave. We're drawing 0.3 amps. I'm just going to let this reset itself. I believe actually that part of that current draw is going to be the fan. But interestingly, I'm actually drawing 0.1 amps. I'm actually drawing 0.1 amps with the remote turned off, which isn't necessarily ideal. This thing should draw absolutely nothing when the remote is turned off. So that's interesting. I'm just going to up the voltage to 14.4 volts and see whether that current draw goes up. So yeah, your amp should draw absolutely no current whatsoever when there is no remote plugged in. Okay, now we're drawing 0.2 amps. I wonder if anything is heating up on here. Now this is going to be quite hard to see because I've just blasted this board with a lot of power, a lot of thermal power into the ground traces, but 0.2 amps isn't really going to be enough to cause anything to heat up really, but eventually it will. Eventually something will show some signs of warmth, which is interesting. So where's that 0.2 amps being drawn? Where's the output inductor on this amplifier? I believe it has 4 output inductors here. These look like caps, but they're actually inductors which are covered in some kind of cloth material and then got an MA audio sticker. So we've got output inductors here and here, and then some smaller final inductors here. These are not capacitors. I think the only rail caps on the board are here and here. But yeah, we're still drawing 0.2 amps. Aha, wait, I see. Wait, I see. Okay, I see where it's drawing the power. You guys probably can't see that on here, but there's a big red spot on here on my thing, and it's pointed right at these driver transistors down here. So I think they're starting to stank a little bit as well. Let me get some alcohol and spray this area and see whether it evaporates from these. Yep, evaporates from the PNP. So that oh, I'm used to looking at where my camera was. My camera used to be here, but now it's here. Okay, so that's cool. That's a good way to see then some leaky components. So like I say, with the amplifier completely off, with just power going into the terminals and no remote, so the amplifier is off but receiving power on the battery terminals, it should draw dead 0 amps. If it draws anything more than that, then there is a problem somewhere. As we can see on this one, by using the thermal imager, I was able to spy a very hot drive transistor over here, which is an A1023, which is the PNP transistor, which is the PNP always dies, which is responsible for sending the drive waves to the output MOSFETs. So what we need to do now then is I am actually just going to go ahead and replace all of those drive transistors with fresh ones, because obviously they did suffer a little bit. They may be damaged but not showing signs of damage just yet. So I'm going to go ahead and replace every single one of those. I need to remember which ones are the A's and which ones are the C's. So by the looks of it, the PNP on this side is, so the PNP's in front. I think I'm going to do these one at a time, because otherwise I'm going to get them mixed up. Although actually it's quite easy, because the NPN always has a positive on the on here. Yeah, that's easy to remember. The NPN always has the positive 12 volts on the pin 2. So that's easy enough to remember, but you know, it's annoying to have to go through that every time. So we've got 1, 2. So if I look on the board here, we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 drive transistors that we need to replace. So let's go ahead and start desoldering those bad boys. And I'm going to do these one at a time, just so that I get them all the right way around first time. So these two here we need to come off. Sound be like PS Audio, Sound be like PS Audio build a 40 watt amp. Wait, PS Audio build a 40 watt amp and charge $500 for their Sprout amp. Yeah, but is it like a horrifically high SQ amplifier? Is it like a proper fucking insane spatial kind of amazing amplifier? Because yeah, 40 watts, it's sometimes not about the power, it's about how the power sounds. I actually burnt myself and cut myself at the same time earlier, which was horrible. I was doing something with the soldering iron. I was pushing up on the board from the bottom because there's huge thermal mass, which is nasty stuff. Yeah, I had the iron underneath the desk like this, and the socket on the top, and my iron slipped, and I was putting so much pressure that it went. The iron went boof like this, and it actually went like I basically forced my 400-degree iron into my palm and then up, and so I cut and burnt my hand at the same time. It's now very sore. John Paul, how's it going, buddy? I just had a good look at John Paul's. John Paul in the live chat. Him and a friend of his are building. It's right. So basically, obviously you're into audio, but you've never done a build before. So where do you start? Usually most people's first builds are like first proper builds. Leave some stuff to to improve on, and don't necessarily do everything right first time. There's a lot of learning involved, but John Paul and his friend is their first real big build that they're doing, and he popped around this evening to pick up an amplifier that we repaired, which was the Vibe 7K, and yeah, the build is actually very impressive, considering it's like a it's one of their first big builds, and I think by the sounds of it, it's sounding really nice. And I'm going to probably do a video feature of it at some point in the not too distant future. Okay, so that one that we just removed was the NPN. So let's drop an NPN in there. Whew, my hand is very sore. That was nasty. That was a nasty burn / cut. I've got fucking loads of PNPs, but no NPNs. Right, here we go. There's one. Just going to use my transistor tester to ensure that these are the right way around. Why you shave your head? I shaved my head because my hair was going very thin. So my hair was going so thin that it didn't look good anymore. BCE 321. BCE 321. One sec. BCE 321. BCE 321. Okay, cool. They're the same pinouts. Yeah, so my hair was going very thin, and it was going so thin that I couldn't actually do anything with it. That looked half decent. So one day I got a bit pissed off and bored with my hair being a bit crap and a bit thin, so I decided, what the hell, let's see what it looks like, shave it all off. So it was kind of a bit more, it's a bit of a joke really. I just kind of thought, this would be funny, see what it looks like all shaved off. But actually, you know what, I didn't mind it, and yeah, I don't think it looks too bad. It's an acquired taste, I imagine, but you never know, I might try growing it out again. I might try growing it out again at some point to see how my hair looks now if I try to grow it. But I'm not too fussed really. It makes life so much easier not having hair. You get up in the morning and you look the same as you did, during the day. This is really not a big deal. It's quite nice having the convenience of not having to do your hair. Plus you get out the shower and you haven't got to fucking dry your hair either. Right, and that's the PNP. So let's go ahead and place the PMP now. Have you an improvement in the ladies with that? No, actually. Okay, so in regards to female attention and female interest with hair versus no hair, what I have found is that with no hair, you get less female interest, but the female interest that you do get tends to be higher quality. So before I shave my head, I might get a fair bit of interest, but it wouldn't always be the highest of quality interest. You know, it's pretty skanky girls, or just well, not all, but just a mix of interest from all different types of girls, from all different walks of life. But after I shaved my head, I noticed that I didn't get as much interest. I didn't get any looks or much flirting when I was out and about and stuff. But what I did find was that girls that did take an interest in me tended to be really intelligent and nice, like honest, genuine, beautiful girls. So yeah, the quantity has gone down, but the quality seems to have improved. So I'm not really too bothered so much by that. I'm thinking of growing it out again though, just to see what difference it makes, just to further my theory. And also, with a shaved head, you tend to give off more of a kind of what's the word? A lot of people say that you appear more sort of masculine and dominant. So yeah, without the hair, you give. Oh well, so I think it depends who you are, obviously, but there's a general consensus that you give off a more dominant sort of aroma, and well, the girls that you might attract are maybe quite submissive. I'm thinking of designing and building a 10k into 1 ohm amp with a rock solid PSU and output stage with a dampening factor of 500, maybe 1000. That'd be really cool to see. Do you mean a car amplifier or like a PA style or home amplifier, Nicholas? 'Cause, I would love to design my own amplifier, and it's something that I plan to do in the future, but my knowledge is not anywhere near enough yet to consider doing that. But it's something that I really want to do at some point in the future. Right, so this is the NPN, that's the 135. I'm just going to empty all these out because I can't see what I'm doing. Yes, for car amp, that would be fucking cool. Yeah, man. Would you use those new types of FET? Someone told me about them in the comments. It's a new. They've started developing now MOSFETs and transistors that don't use silicon. It's some other material, and I can't remember what it is. But it's apparently a whole lot better. Nicholas, you probably know what it is, but I can't remember the name of it. Would you use those FETs instead of old silicon FETs? That would be interesting. So we've got 1, 2, and 1, 2 there. 1, 2 there. Taramps, I think Taramps are actually starting to use those FETs already. You know, the ones that aren't silicon. I'm pretty sure I've seen them in Taramps amplifiers. They're pretty expensive, but they're not too expensive. They're like a bit more expensive than silicon MOSFETs, but not like horrifically more expensive. A bit, but not like crazy. Gallium nitrate, yeah, I think that was the one. Yeah, GA. No, sorry, GN. Yeah, I think it was GN. Yeah, gallium nitrate. I think that was what it was. Do car amps need external fans? Some of them would benefit from an external fan. Yeah, it depends on the amp and depends on the size of the heatsink. Depends on its design. Some amps benefit from a fan, but not all of them need it. Mostly it depends on the heatsink design, really, and how many heat generating components are mounted to the heatsink, or you know, if there's any heat generating components that are on the board that aren't actually heatsink, then yeah, maybe you could do the fan. Gallium nitrate FETs are good for very high switching with low RDS. Good for full range. They're quite expensive. Yeah, I heard that they were quite expensive as well. But like, not crazy expensive though. Like the ones that I saw, or the ones that I heard, they were, yeah, they were a bit more expensive, but not like really more expensive. Like maybe instead of being like £2 or £3 a FET, they were like £5 or £6 a FET. So okay, maybe like double the price, which is quite, I guess that's quite a lot. But like, you know, I was expecting like sort of £10, £12 a FET or something crazy like that for some new technology, but it wasn't like that. So I guess that's why the tar amps amplifiers, I guess that's why they're all the 10Ks and stuff, they're all full range, because they're using GN FETs. So they can be. What's the 90N20D? That's a silicon FET, isn't it? I'm pretty sure that is. What's that there? 90N20D. Is that a silicon FET? Right, so at the moment I'm just working out which of these, so basically I just went ahead and removed all 8 of these drivers, and I didn't pay attention to which ones were the PNPs, which ones are the NPNs. The reason I didn't bother to pay attention to that is because it's very easy to tell which one is the PNP and the NPN, because the NPN will have pin 2 connected to the 12 volts of the battery. So if we do that and we find which one has the continuity, which is this one, so we know that the NPN is the one at the back here. It's very easy to do. And so therefore the PNP must be the one in front. And the same for the other side. Yep, so this one is the NPN at the back. I need to scrape off some of this CA glue. There we go. PNP at the front. Okay, cool. So that's all 8 drivers that I've just slotted in. So I'm just going to solder those in, and then we're just going to make sure that the whole drive waves look good everywhere else. And then, fortunately, fingers crossed, this might be a very basic, simple repair. If it's just the drive transistors and the power supply FETs, then this is a nice, simple repair. I haven't heard the name MA Audio since years ago. Yeah, it's I don't really see a lot of this in the UK anymore. For low voltage up to 100 volt, it's not too expensive, €6. Yeah, it's not too bad. Have you heard biofets? No, I haven't heard biofets. What's that? Some kind of semiconductor that uses some organic material, some organic matter. Sounds like something from a science fiction movie. Elena, hi, how's it going? Good to see you. So just an update for you guys who watch my stream regularly of other amplifiers that I've had in the workshop. So the Rockford Fosgate, the BD 1500.1, fully repaired, and that benched, right? Actually, what do you think it benched? What do you think the Rockford BD, the Punch BD 1500.1, what do you think it benched? Bear in mind it's a 2 ohm amplifier. It's a 2 ohm stable amplifier. So what power did it make at 2 ohms? Okay, so we've got the first guess is at 1800. What do you use for drivers? For the NPN I use BD139. For the PNP I use B772. The 140 is a little bit slow and not the best PNP for this job. The 772 is a lot better, a lot stronger, a lot quicker. 140 will work fine, but you know, we're choosing the best of the best here, guys. I only accept the best of the best. Ouch, that was hot. I just leant on the pad I just finished soldering. Not a good plan. Fucking hell. I really hate these fucking pads. There's so much thermal mass around this area and so much shit in the way. Can't get a decent suck on it. Fucking annoying. Do you make good money with amp repairs? I wouldn't say good money, it's like enough. It's okay. It's enough money to be able to do what I enjoy doing and live. But I'm never, let's be honest, you're never going to get rich doing this amp repair stuff. The way to get rich with this, with doing this thing, is to design your own amplifier brand and then market and sell that. That's how you get rich, or you know, more wealthy. Not like super mega rich, because car audio isn't huge in the UK. I don't think anyone has ever got like filthy rich from car audio. Like, but yeah. any reason you prefer the vacuum solder sucker over desoldering gun you modded to your station? The desoldering gun I modded to my station is fucking shite, and the reason that it's crap is because so obviously there's there's a tube. So the idea with the desoldering gun is it heats up the tip, and then the tip obviously is connected to a tube that the solder flows down and sucks away into the canister, the thing on the end of the collection canister inside. And the problem is that the tube that the solder flows down from the tip doesn't get hot enough right at the back. So what happens is when you're sucking solder, the solder hardens and sets before it exits the tube, and it all gets stuck at the back of the tube. So the thing isn't getting hot enough, really. Well, it's getting really, really hot, but just not at the back of the tube where the solder needs to pass through. So what I end up doing is every time I use the solder sucker, I'll do like 4 or 5 holes with it, and then it will stop working, and I have to take the thing apart and I have to try and get the stuck solder out. And the last time it got stuck so badly that I haven't actually been able to get the solder out of the tube. So yeah, I give up with that bullshit. I'm saving up for a HK-4000D or something better. But to be perfectly honest, I mean, I do, like, this is just so easy. Like, the solder set, I haven't got to wait for it to heat up. It does the same thing. I know how it works. It has the silicone tip, so it makes a good airtight seal. This works really well for me, and it's just really fast. So even with the HK, I don't know whether the HK is going to improve the speed and efficiency of my work enough for what it costs. But the only way to find out is to buy one and try. Which is why I want to buy one at second-hand price. I want to buy a used one, so that if I don't get on with it, or if if it's actually just ends up being quicker, me using the manual sucker, then, at least I can sell it on for roughly the same price that I bought it for, rather than buying it brand new and losing out on a whole bunch of money. Right, that's all our drivers fitted. Let's put all these back in my drawer. There's a lot of these. I ordered absolutely tons and tons of these things, so I didn't run out. Yeah. I wonder how long it will take me to get through all these. Okay, so the new drivers are fitted. So before we had with the old drivers in, when I just turned the power supply on and didn't even turn the remote on, didn't even send remote signal to the amplifier, it was already drawing 0.2 amps. And the reason for that was we found was that one of the original driver transistors was getting really hot. And we were able to see that with our thermal imager. So that means that it was leaking and it was passing current. So I've gone ahead and, just for good measure, I've replaced all of the drive transistors, because it's good measure to do that. They don't cost much, and they obviously were put under some stress, the fact that some of them died. So hopefully now I should be able to turn the power supply on to get the 12 volts at the battery terminal, and it shouldn't draw any current anymore. Have you had a chance to see the fan? No, actually. So basically, Nick, on a lot of amplifiers that I repair, we have to use the IRS 21844S, which is the half-bridge drive IC, and the 21844S is used in like so many amplifiers across the whole range. And Nicholas was actually suggested to me that we try a different type of drive IC, which has the same pinout and has the same function as the 21844S. he suggested that we use the FAN 3122, I think it was. And I actually ordered 4 of those. And here they are. So I have actually ordered 4 of these, which are supposedly much better than the 21844S. They will allow me to use lower RDS FETs with a higher total gate charge and input capacitance, which means I can get better FETs on the output sections of these amplifiers, and they can still be driven perfectly fine with the driver IC. So yeah, I'm waiting for the right amplifier to appear on my bench to try those out. How do you replace an IC in a tight spot? Use a hot air station and tweezers. Okay, cool. Let's try this then and see what happens. So, I'm going to turn my power supply on. I'm going to take it off of 14 volts. I'm going to knock it back down to 10 for a minute. Okay. Alright, so I'm only going to let 0.8 amps pass again. So, okay, fantastic. I've just plugged the amplifier in and it's now drawing 0 amps. So it's not drawing any current anymore, which is great news. So now what I'm going to go ahead and do is take my oscilloscope probe and go around and check all of the gate pads to see if we have good gate drive on all of these pads from the drive circuit. So let's apply the remote and let's see what we have. Oh yeah, that looks nice. Okay, so we have the fan, the LED has come on, the relay is clicked in, so now we're drawing 0.2 amps, which is normal because we have the amplifier powering a fan, it's powering the coil of a relay, and it's powering the drive circuit. So, the drive waves that we have on here are 30 kilohertz and they are 5.6 volts RMS. So I'm going to go ahead and check every single bank and make sure that these are the same. So we need 5.6 volts RMS. Yep, that looks good. I'm just going to go ahead and check every single bank. It's very important that every single one is identical. And my scope has the ability to pause and restart the wave, the operation, so I can actually see differences in these very clearly. Now, interestingly, this isn't gonna cause a problem, okay? But I'm just gonna zoom into my scope so you can see this here. I'm gonna shifty that down and zoom in. Actually, I need to AC couple and then shifty it down a bit. Okay, so this, I've just zoomed into the top of the wave. So this is the top of the waveform for the power supply. So you see how thick the top of the trace is there? My scope cam is a fucking potato, so that's why, yeah, apologies, it looks really nasty. If I pause that, and I go ahead and probe the one over here, you can see that it's a bit thicker. You see how that's a bit thicker? And if I go back to the other one, that's now thinner. That's now thicker. So that's not going to cause any problems whatsoever, but I thought it's just interesting to show you the advantages of having a scope that allows you to pause and restart the operation, so you can make out tiny differences like this. Sometimes tiny differences like that will pose a problem, but in this case that's absolutely fine. That's probably just the difference between how far away these FETs are from each other. So that's a 4.2 volt RMS wave. Oh no, it's the same. My scope, in order to read the voltage correctly, it needs to actually have the wave nice and big on the screen. So this is actually a 4.2 volt RMS wave. And there's a pretty burnt looking gate resistor over this side. It's still doing its job by the looks of it, but I'm going to replace it anyway. So any visually burnt gate resistors we need to replace. But I think mostly these are all actually still doing their job. They're passing the drive. Yep, that looks good as well. This bank all looks good. Okay. That bank's very thick on the top there. Look, that thickness of that compared to that, it's about, actually no, it's about the same. It's a little bit thicker, but okay. Yep, So the gate drive looks great on all of these. The only thing that I do want to do is replace a couple of these gate resistors that look visually burnt, just to ensure that the resistors don't kill themselves after some time. I'm just going to make sure that nothing is getting hot on the board. So using my thermal imager, I can see that the only things that are emitting any small amount of heat is the center of the fan, because obviously the fan has some coils in there. That's how the fan works. So the middle of the fan is sitting at about 30 degrees. That's fine. Nothing else on the board should be heating up at all. Let's zoom in here. What we got down here? Okay, we've got 44 degrees on a resistor down here. That could be fine. Depends what it's doing. So there's 42 degrees on something in there. That could be not a problem. If a resistor is dropping voltage across it, then it will get warm. The relay is getting warm, of course, because the relay has a coil in it and it's holding the switch open. That's normal. And I think that's the only things that are getting slightly warm. No problem. I'm just gonna see, out of pure interest, what it is over here, which resistor over here is getting warm. So I can spray some isopropyl alcohol. If it sprays, and see what evaporates. Now these resistors are actually very hard to spot when they evaporate the alcohol off, because they're kind of shiny already anyway. I don't think I can quite make out what is actually warming there, but it's probably fine. If we've got a resistor which is dropping voltage across it, then that's perfectly normal. Oh wow, okay, what's going on there? That's an interesting looking wave. Is that supposed to be there? That's on one of the resistors here. The problem is without a schematic, it's kind of not too easy to guess what these should be doing. Aha! Okay, I see the issue. I see an issue anyway, at least, right? So check this out. This is this is really interesting, right? Check this shit out. This is possibly why some stuff is heating up over this area. So we need to deal with this. So if I zoom in with my zoom in camera, and I zoom in on this area of the board here. Can I do that with this camera? I need to shift this over the other way. This is really interesting. I don't think I can get that more in camera. There we go. Right, you can kind of see that, right? So here we go. I'm going to turn the amplifier on again. Okay, amp comes on, light turns on. So if I probe this resistor here, okay, we get nothing really on the scope screen. However, if I move my oscilloscope probe across the PCB, oh, it's not going to do it now, is it? It's doing it a minute ago. If I spray some alcohol, maybe it will do it then. Spray some alcohol. Look, check this out. If I move my probe across the PCB, it's actually conducting some voltage in the kind of messy stuff that's in here. So in the mess, in the dust and in the crap that's on the board, it's actually conducting some electricity, and there's some voltage on the dust. So we need to clean that off. So where's my toothbrush gone? Actually, I'm going to use a cloth for this one. Hey Jesse, how's it going? Oh, anyway, I didn't tell you guys what the Rockford bench. So the Rockford BD 1500, I actually got 1,730 watts RMS out of that at 2 ohms, which I thought was very impressive. I was quite impressed with that. Yeah, not too bad. So that was a successful repair. We also did a successful repair on the Ground Zero 4K, which had the absolutely obliterated power supply drive circuit. So I've uploaded a video of that one actually now separately, because I thought that was worth watching. And we also repaired the Vibe 7K, which had a blown output section due to vibration damage. What kind of scope probe do you have? It doesn't look like it has a ground wire. It does have a ground wire, but I've actually grounded my scope directly on this scope. The scope has a ground pin on the scope itself, and I've run the ground to the output, the negative of my bench power supply, so I don't have the extra wire trailing off of the end of this, because that's kind of annoying. Alright, let's see now. Okay, so we've got 10 volts on this resistor and 2 volts on the other side. Okay, so this resistor is actually dropping 10 volts down to 2.9 volts. So this one will probably get a little bit warm because it's dropping quite a bit of voltage across it. These other resistors over here, what are these guys doing? Not a lot by the looks of things. This one has this interesting looking wave on it. But again, I don't know whether that's intentional or not, because I don't have any schematics or anything for this, so no idea whether that's meant to be there or not. This capacitor has some small pulses on the negative rail and has that on the other side. Okay. I mean, it's probably fine. We've got a regular 494 here doing its job, so yeah, pin 3 of the 494 should be low, which it is. Pin 4 should be low, which it is. We should see a nice sawtooth wave on pin 5. I think it is. Where are we? Oh fuck. Yes, the sawtooth wave is very high frequency. Oh no, yeah, that's correct. Yeah, so yeah, we've got the sawtooth wave at 62 kilohertz on pin 5 of the 494, which is normal, and then the square waves on pins 9 and 10 of the 494 will be half of that frequency at 31 kilohertz. That's how this thing works. So that looks good to me. And we've got the same gate drive on all of these power supply FETs. So I think we're ready now to fit some, well, I'm going to change one of the gate resistors over here that looks a bit burnt. Once we've changed the gate resistor that looks burnt, I'm going to go ahead and put some power supply FETs in and just make sure that the output section wasn't damaged at all. So to replace that gate resistor that's bad, it looks a little bit visually burnt. Just so you can see what I mean by visually burnt gate resistor, I'm going to just zoom in on it over here. So yeah, this resistor, you can see it's got like a black banding around it. This has got very hot, so yeah, we can go ahead and replace that. Just need to make sure, double check what resistance all these should be. So we've got 47 ohm gate resistors. That's nice and easy because I've got tons and tons of those. This one that's blackened does still read 47 ohms, but yeah, the fact that it's actually gone blackened like that means that I'm going to go ahead and change it. I'm just checking that the rest of them are all 47 ohm, the ones that I can't quite see that easily underneath the bars. 47, yep, looks good to me. I'm an hour late. Ah, well, this stream's been on for an hour already? Holy crap. I'm going to get back to doing work. Done in an hour, so hopefully you're still streaming. Oh, cool. Yeah, absolutely. I shall join you later. I always like having Jesse on the stream. It's good. It's good chat. Alright. And, 1 second, guys. Phone is ringing, so the stream will probably cut out. That are running together with that one that's dead. I'm having problems finding them in the US. I will help you in a moment find a suitable replacement, but if I help you find a suitable replacement, then you need to replace all of the 264 ends with the new replacements. You can't just put a random new replacement in that location. You have to replace all of them. Do you buy from eBay? No, I did used to buy from eBay when I first started doing amplifier repair, and I learned very quickly the hard way why you don't buy from eBay, because I got myself a lot of fake FETs from eBay, a lot of fake parts, and had to buy them again from a reputable source. So yeah, I don't recommend buying your parts from eBay unless you can see that they are like from a genuine seller. That, you know, basically don't buy them from China. But I don't recommend you buy them from eBay anyway. Yeah, get your FETs from a reputable source. There we go. I'm placing all 4 in the amp. Oh, okay, cool. Yeah, I'll help you find or someone else in the live chat maybe will be able to help you find a suitable replacement for those. I feel like, what are they? IRFP264. Are they a 200 volt FET? 264. I feel like I've used those before, but I can't remember what they were off the top of my head. Alright, so yeah, we replaced that one gate resistor. So now I'm going to go ahead and take my whole massive drawer full of 064 ends, which is what this power supply needs. And let's load up 1 FET per bank and see if the thing wants to come to life. Now these are probably not going to go in the holes very easily because it was a nightmare taking these FETs out and doing sucking the holes. So I probably haven't sucked the holes very well. And this is probably going to take me absolutely hours to actually fit the FETs back in place because due to the thermal mass of this area, which is so annoying. Let me just try and find some ones that it'll actually slide into just for this live stream, and then I'll fit the rest of them off stream because this is going to take far too long otherwise. Is this one going to work? Is this one going to go in? Okay, cool. Yeah, so we've got one that goes in here. That's good. So in terms of MOSFET banks, We can tell whether whether any of these MOSFET pads are in parallel by checking continuity on the gates before the gate resistor. So if we go before the gate resistor, so where your gate resistors are, if you probe before the resistor, so on the board side, any that are in parallel with each other, we can just fit one FET in that bank. So we've got 1, 2, 3, 4, 5, 6. Oh wow, okay, so I actually only need to put 4 FETs in this, potentially. Because we've got 2 transformers, and so each transformer will need 1 0 degrees, 1 180 degrees. So yeah, wow, okay, cool. So I only need to put 1 FET, I need to put 4 FETs, so 1, 2, 3, 4. Interesting, cool. So these are just all in parallel with each other. So 5 there, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, cool. That makes life easier for the live stream anyway. That resistor looks like a carbon composite resistor. Yeah, it's a different type. It's a flame retardant resistor. This one. It doesn't make a difference. For the gate resistor, it doesn't make a difference. What are those dong, ding, and kur sounds? What dong, ding, and kur sounds? Oh, it's probably WhatsApp. I haven't checked my WhatsApp in ages. WhatsApp makes those noises, but yeah, I've been very bad with checking my WhatsApp recently. So I'm probably getting tons of messages from all sorts of people. Right, that's 2, and 2 more to go in. Then we can power her up and see what happens. Hey, Seth is on stream. How's it going, buddy? Can I replace an electrolytic with a ceramic cap? Depends. Really depends on the circuit. FDA 59N25 might fit, but you might need to change the gate resistors. I would suggest 69N25. Actually, if it's a 250 volt FET, I would use FDA 69N25. These are fantastic FETs. I've used these in a whole range of amplifiers. Yeah, they're 250 volt obviously, and they're 69 amp, and they are very easy to drive, and they have a low input capacitance. Yeah, I've used these all the time. FDA 69N25. I've used those with very good success, and I don't remember changing the gate resistors on many amps that use those. Thumbs up, David. Your live streams are great. Regards from Germany. Thank you very much, Fred. Cheers, buddy. Let's appreciate the kind words there. That's number 3 and number 4. How does the pedals camera switching work? The pedal on the floor, it's just a USB triple pedal thing, and all it does is it just inputs characters like a keyboard. So at the moment, I think its default setting is pedal 1 is A, pedal 2 is B, pedal 2 is C. So it types that like a keyboard does. I think I can program it to do different things, but I haven't done that yet. So at the moment, it's just literally A, B, C. So I could do the same thing on my keyboard, A, B, C, but the pedal does it as well. Which is why I'm forever typing on the chat, which is why I'm forever typing BBAC because it's just that's the pedals doing that. All right, let's solder these single FETs in. So we've got one FET per bank. Solder these in, and then we can turn the amplifier on and see whether it's happy or not. See what it does. Helps if I turn my soldering iron on. There's so much thermal mass on the boards on these. It's a nightmare to work on. I don't recommend working on one of these if you are new to amplifier repair or new to soldering. It's not a nice board to work on. Okay, right, that's our 4 FETs done. I'm just going to add some more solder to this ground trace, this source. Oh, I really hate the source traces on these amps. There's so much thermal mass, it's horrific. Nasty, nasty. I mean, it's a good thing, really. It's a good thing that there's so much thermal mass, but it just makes it a nightmare to work on. Right. I'm just going to give that a minute to cool down so I can actually tell whether the FETs are heating up from operation or from soldering. So I'm just going to wait for these to cool down. Now, before I obviously power it up, because this is gonna build the rail voltage and it's gonna enable the output section, I checked earlier. I didn't seem to have anything wrong with the output section. We had no shorted FETs over here. I think it was just this small piece of copper wire that shorted out the power supply. The power supply FETs. If you saw the stream earlier as to what happened, why this thing died. I'm just going to clean that off a little bit though. It's a bit dirty around here. How do you determine what capacitors you need? How do you measure them? It says initial pro. I'm not sure if that was. I'm not sure if that question was to me actually. The question might have been somebody else. IXFH-80N25. Nicholas is giving out all the good info all the time. It has 4.5 times less RDS, will not get as hot. IXFH8. This is cool. See, I take on Nicholas's advice all the time. It's fucking great. Nicholas gives fantastic advice. So let's see. I have been for a 250 volt FET. I've been using 69N25, which works out nice and cheap for me. So I am going to go ahead and see what how much the IXFH80N25. How much that costs. I'm not sure my internet's going to be quick enough. There we go. Okay. Have you ever worked on an amp that happened broken screw had broken wait what? That happened broken screw down terminals for speaker outputs and power ground? Like if they're snapped, you just have to solder them back on best you can. You have to solder the snapped bits together. Yeah, you can't get them anywhere. You want the best 250 volt MOSFET with the lowest gate charge. Go on. I'm all ears. I'm all ears. I'm curious now. Okay, so we can buy. Oh fuck, Nicholas, these are expensive as hell. IXFH80N25. These are fucking crazy expensive. Whoa. Okay. Yes, on this website it comes out about £2 a FET for the FDA 69N25s. For the other ones, it works out about, what's that? 92 divided by 30. 92.7 divided by 30. It's £3 a FET. So it's an extra £1 per FET for those ones, which isn't like a crazy amount, I guess, but it's enough that it's going to make a lot of. It's going to mean that you make less money doing your amp repair. So it's only worth doing those upgrades like that if you say to the customer, I can upgrade these FETs, but this is going to cost you X amount more money, rather than just charging the customer for it anyway, because that's going to make the repair costs go up quite a bit. Right, what's Nicholas say? Here we go. According to Nicholas, here we go. The best 250 volt FET is the IPP 200N. Fuck! That model number looks like it has 200 amps. Wait, let's see how much this bad boy is. I wonder if this is even on this website. That's not that expensive. Wait, hang on. This is a 220. This is a TO220. Did they make this, Nicholas, in a AC 27? Wait. I think it's AC274, isn't it? Which is the package that I usually use. TO3PN. They're very similar to TO3PN. Sorry, excuse me. Alright, so there are these FETs should have cooled down by now, which they have. These FETs have cooled down a fair bit. So I can't see any short circuits on the output section, so I am pretty happy to go ahead and power this thing on, and let's see what happens. So this should come on fully now then, if everything has gone to plan. So I'm gonna allow 4 amps to pass. Only 4 amps to pass. 64 NC gate charge. Wow, fuck, that's pretty good. That's crazy low for the type of FET that is. Right. So we're going to probe the power supply first, so you can see that on the scope up there. And I'm just going to apply the remote and let's see, does it come on? Okay, so yeah, we can see that I just pulsed it for like literally 2 seconds to show that the power supply was working fine, which it looks like it was. Now, that small pulse should have charged the outputs to some extent. So as you can see here, we've got a bit of voltage on the outputs. We've got 2 volts on the high voltage rail and minus 2 volts on the low voltage rail. So I'm going to give that a bit more power. We're going to probably get that down to about, I'm probably going to allow 10 volts on there for a second, and then we're going to check the output section. Whoa, okay. That's 4 volts. Okay, still only got 3 volts on there. Positive, nothing positive, negative, nothing negative. Okay, this amplifier works in an interesting way. This amplifier has RFP. Right, so this amplifier is using N-channel and P-channel MOSFETs. I didn't even think to look at that. I hadn't actually rubbed off any of the thermal paste from the output section FET. So this channel is using N-channel and P-channel MOSFETs, which means that on the high side, we should have positive rail on pins 1 and 3 and nothing in the middle on pin 2. On the low side, we should have a negative rail on pins 1 and 3 and nothing on the middle either. Okay, so let's go ahead and turn this thing on fully and see. Okay, it's trying to come on and then fails. Oh, the power supply FETs are getting pretty hot. Well, not hot, they're getting a little warm. Okay, I'm going to allow some more current to pass. I'm going to allow 8 amps to pass, and let's see what happens. I think it's trying to build the rails almost instantaneously, which is why it's struggling to. There we go. That worked first time, so it just needs a bit more current to come on. So I'm going to get that thing to come on fully again one more time. And this time I'm going to probe the negative rail. I'm going to turn my input voltage down from 11.8 volts. I'm going to only allow low voltage to pass. 10. I'm going to allow 9.8 volts into the amplifier, or 10 volts when it levels off. And let's turn her on again and make sure that it works. There we go. Amps drawing 2 amps with the thing on fully. We've got low side drive, high side drive is there. That's high side drive and low side drive. So the output section appears to work fine. The power supply FETs are staying nice and cool now that I've allowed 8 amps to pass, so the thing comes on first time. So I believe this was a relatively simple repair and we have a success. That is all following on a bench test and an endurance test. Because the amplifier, we never know if it's fully fixed until we bench test it and endurance test it to make sure. But as far as I can see, if I leave it on for a bit longer this time, let's check the power supply drive. So this looks like a regulated power supply section. So you can see the wave isn't a beautiful square like so. It's yeah, you can see that the actual gate drive is quite a low duty cycle there, and so this means that the power supply won't be driven full duty cycle until the amplifier draws current, which is quite a good way of doing it. So yeah, that looks pretty good to me. That looks good for a low duty cycle. And on the outputs of the inputs of the rectifiers, we can see there that we've got that low duty cycle wave is amplified. It looks almost like a house with a chimney or something, which is pretty cool. So as long as that's the same on all sides, then it should be good to go. Yeah, looks good to me. I'd say we have a successful repair following a bench test and an endurance test. Good stuff. I think that about wraps this up. Yeah, let's see what's going on in the live chat. Chevys and Hondas, how's it going, buddy? Cool. So, nice, easy power supply section repair. And yeah, the cause of that then does seem to have been from the small strands of wire that were floating around inside this amplifier. So now what I've got to go and do is I've got to go and solder all those the other FETs in, which is going to be an absolute nightmare because it's very, very, very hard to successfully remove all of the old solder from these holes because the thermal mass is so high. And so there's always some solder left in the holes. It's going to take me fucking ages to do that. Cool. Did everybody enjoy this live stream? This wasn't the most exciting of live streams because it was just a basic power supply repair, but oh, Nicholas, yeah. I will eat. To be fair, Nicholas, with this amplifier, earlier when I was off of live stream and I was removing the old FETs, I preheated the amplifier using this fucking great big heat gun. And I preheated the whole amp and it was really, really warm, quite warm. But even so, there is so much thermal mass on these pads, it was still a nightmare. It took me ages to remove all the solder on all the FETs. But yeah, I hate to think what it would have been impossible if I hadn't done that with this. If I hadn't preheated it with a heat gun, it would have been impossible. Cool. You also need a 120 watt iron. I wonder what wattage this is actually. Shall we see how many watts my soldering iron is? AOUA, I think that's how you spell it. This is a 2738A. So let's see, how many watts is this thing? Oh, this is A plus. Oh, it's the A plus. It's the plus. Okay, let's see. Does it say how many watts this is? Ah, okay, I think it's only a 70 watt soldering iron. I think, yeah, it's only a 70 watt. So yeah, 120 watt would be a really nice improvement actually, yeah, for sure. The hot air gun is 500 watt. And it's a 24 volt output voltage on the iron. So yeah, a 120 watt would be nice on the soldering iron side. If I was sharp, that would help me out, I think. Okay, well, I think that about wraps it up for this stream. Thank you very much for tuning in. I hope this one wasn't too boring. Basic power supply repair, but we saw some good methods for testing the, well, yeah, we saw a good example of how the amplifier shouldn't draw any current at all when there's no remote applied, and the fact that it was. We saw that there was a drive transistor heating up, so that was good to see that in practice. What else did we look at? Looked at some conductive dust on the board, which is why it's important to clean the board off properly. Yeah. So, nice and easy repair. Hope you guys enjoyed. I shall probably catch you either tomorrow or Friday for the next live stream. So yeah, thank you very much for watching, guys. I'll see you later.